So we're looking at an example of a percentage yield calculation. So the reaction of interest involves butanol or 1-butanol, which is C4H9OH, reacting with sodium bromide, and this will give us bromobutane or 1-bromobutane, so that's C4H9BR. We also get a side product or a byproduct being formed here, which is sodium hydroxide, NaOH. So in any question, as we said before, you will always be given the amounts, okay, so the masses of starting materials used, and you should be given the molar masses, or you should be given enough information to calculate them yourself, okay, so having access to a periodic table. If being asked to determine the percentage yield, you will also be given the actual yield or the experimental yield of the product, okay, and again, it's molar weight. So let's have a look here. So we said in the lab that the first step is always to determine your limiting reactant. So we have two reactants here. We have C4H9, this one here, and we have NaBr, okay, sodium bromide. And we want to find which one of these is used as your limiting reactant and which one is used in excess. So we do that by figuring out the number of moles. So step one is the limiting reactant. Both of these are solids, so we don't have to do any density conversions or anything like that. We can just determine the number of moles of each. So for C4H9OH, to find out the number of moles, say moles is equal to mass used divided by its molar mass or its molecular weight. So that is the same as saying 5 grams divided by 74.12 grams per mole. And that will give us 0.067 moles. And we do the exact same now for sodium bromide. So mass, moles is equal to mass used divided by molar mass. And so that will say 10 grams was used, and we're going to divide that by its molar mass, which is 102.89 grams per mole. And when we divide that, we will find that we get 0.097 moles. So to figure out what our limiting reactant is, we look at both of these numbers and we see which one is smaller. And this number here is smaller, okay, so we use less moles of our 1-butanol than we do for sodium bromide. So that means this is our limiting reactant. It also means that our sodium bromide is used in excess. So we have an excess of that left over. So what we do then is we want to figure out if we only put in 0.067 moles of our butanol, that means we can only get 0.067 moles out of our product. Okay, that's the maximum number of moles we can get out of our product. Moles are all well and good, but we can't quantify them, we can't work with them in the lab, they're not tangible. What is tangible is mass, okay, we can weigh out something. Okay, so we want to convert these moles into grams. And to convert moles into grams, we multiply the number of moles by the molar mass of what we're interested in. And what we're interested in now is our product. Okay? So now you're going to go from moles to grams. This is also figuring out your theoretical yield. So as I said, you're going to take your number of moles, which is 0.067 moles, and you're going to multiply that by the molar mass of your product, which is this 137.02 grams per mole. And when we get that, we will find that it is 9.18 gram. And this is our theoretical yield. And we've mentioned this before, this is the absolute maximum mass of product that we can possibly make in the lab, assuming the most perfect conditions. The likelihood of us ever making that theoretical yield is slim. Okay, then finally we're going to do our percentage yield. So our percentage yield involves us taking the actual or the experimental yield, and that's been given to us here. Okay, we said that there was 5.2 grams made, and we're going to divide that by the theoretical yield. So that looks like 5.2 grams divided by 9.18 gram, and we want it as a percent, so we multiply by 100. And that will give us 56.64%. Okay, and that's an okay yield. Okay, it's not amazing. We typically say anything above 70% we're happy with. Anything below between 50 and 70 is good to moderate, and anything below that then we start to say it's not a great reaction. Okay, it's not overly efficient. But that is your example of your theoretical yield and your percentage yield, and as we said, the steps will never change. It's just making sure that we have both products as solids first. If we don't have them as solids, we must use a density formula to go from volume to mass, and then everything remains the exact same. Okay, so give it a go yourself, and if you do have any questions, please feel free to ask in a lecture, in a lab, or email, or whatever suits.